it.
Something went wrong.
Something went wrong with the screen share.
Are we loading?
Okay. So we're going to move on to, this is kind of our very last Algebra 2-like thing before we get into, we have to do logarithms and exponentials, and then we are moving on to trig. Okay? We haven't done trig yet. Have you seen sine, cosine, or tangent yet? That's trig. That's the geometry part of trig. Yes. That part, yes. There's way more to trig than that. We could teach a whole semester on trig. We kind of condense it. Okay. There are some classes in college that are just trigonometry. All right. So, we're basically gonna do this last little thing. Okay. This is the only topic that's going to be on the next quiz. Okay. But there's a couple of different ways we can solve this problem, so that's why we're going to make it just its own quiz. There might be 2 or 3 of this type of problem on the quiz. Okay, but there'll be different types and things you have to do differently with them. Okay, all right. We are going to read that out loud together. I don't think there's anything in there that you probably can't pronounce. What's wrong? You're right. Apparently, I can't do English and equation. There we go. Thank you. All right. Everybody got that? Not A-N. Apparently, I can't type. All right. So, on the count of 3, we're going to read the yellow dot sentence, or the yellow square sentence. All right. 1, 2, 3. All right. This should be a really radical lesson, right? All right. Okay. I got a couple people to laugh. That's amazing. All right. So, when you laugh at the bad jokes, that's great. All right. Here's what I want you to do first. Okay. We're going to do a little bit of exploring. We've kind of done this before a little bit. I'm not intending to spend a whole lot of time on this. I want you to read that paragraph right there. Okay, so you're reading that to yourself really quick. Shh, to yourself, read it. Okay. We're going to try to do this little exploration without getting out our calculus because they gave us a picture right there. Okay, and we can use that picture. So when we did quadratics, what shape does a quadratic make? What's the shape of a picture of a quadratic function? It's a U, right? So that's a picture of a quadratic, okay? We learned that we could have a solution like that where it crosses twice. So you could have 2 solutions. We learned we could come down here and have it where it crosses once and have 1 solution. Or we could have it where it doesn't cross at all. And we might get imaginary solutions or no real solutions, but it looks like it has no solutions. Okay, so that's where they're saying 0, 1, or 2, and they're always careful to say real solutions because that doesn't mean we can't have imaginaries. Okay, same thing with this one. We might end up with some imaginaries maybe. Okay, all right, so here's a picture of a radical function. Okay, it's shifted a little bit. Remember how we go in or out of parentheses and we change the sign? So you notice how it's shifted like 3 to the right instead of to the left. So that shifting thing hasn't changed. Okay, the HK thing that we talked about earlier in the year. Okay, all right. It wants us to look at the graph of y equals 2. That's a horizontal line when it's y equals like that. So let's just draw the graph of y equals 2. Okay, so it would just be right there like that. Okay, looking at that, how many times does it cross? 1. So how many solutions are there? 1 solution. How do we know? Because it only intersected 1 time, right? So because the graphs only intersect once. So because graphs only intersect once. Okay, I'm going to use a different color now. Okay. So now it says we're going to get rid of the y equals 2, and now we're going to do y equals -1, which would be down here somewhere, right? So I am looking at the black function and the green line. How many times do they cross? None. How many solutions then? 0, right? 0 solutions because do the graphs cross? No. Because, I just did my shortcut because. B/C means because, okay? Because the graphs do not intersect. Do not intersect. Okay. Oh, we ran out of graph. Okay, we're gonna have to use Desmos now. Okay. All right. Let's go to Desmos. So everybody open up Desmos, and I want you to put this graph in. So everybody's going to put a y equals and put that in. Okay? I'm going to go do it too. All right? So y equals... Okay, so to get the square root... Oh, my thing is in the way here. You can use the little keyboard symbol, and it's right there. Or the shortcut is SQRT. Okay? So you guys know, because it affects you. College Board just published today that there are now we don't offer all of them, but there's going to be 9 exams next year that are completely digital. It's not math yet, but it could be coming. So it's somewhere in college you're going to have to type math probably, right? So starting to learn some of like the shortcuts like SQRT helps. Okay. All right. X minus 3, X plus 2. I want to say it was like both Englishes, the computer science principles, Euros going digital next year. Yeah. So do you guys remember, no, you guys didn't take, so juniors took SATs digital or PSATs digital this year? No, yeah. Everybody took digital PSATs, right? So they're switching to that application for the AP exams. So because it's a lot easier to transport the documents. Think about how many hundreds of thousands of paper booklets they have to transport around this country to get it graded. It's a lot. Your score is safer if it's digital, right? They can't lose your booklet. So, and the cost of that could be amazing, right? So, you like the stickers? I know. The stickers are cool. So, if I ever have to fill out a survey for College Board and lodge a complaint, I will complain that you still need your stickers, okay? So, all right. So calculus isn't going digital next year. So you still get a paper test and you can get your stickers next year, okay, for calculus. All right. So let's look at this one now. Okay, so there's my function. And did you notice how I shifted my graph? All I do is just pick it up and drag it. So you can drag it more if you want to kind of balance it a little bit better on your screen there. Okay. All right. It says over here back on my notes that we're supposed to add in the graph of y equals 3. Which really means what we're doing with this is we're basically putting 2 sides of an equation, right? We're trying to decide how many times it crosses. So I'm going to put in y equals 3. Y equals 3. All right, how many times does it cross? 1. So how many solutions? 1 solution. Okay. Oh, well, that's not good. All right. Now it says to put in, what are we going to replace the 3 with? 1. Okay, so everybody do that. I'm not going to do it for you. You do it. So take out the 3, put in a 1, and write down how many solutions it has. All right, what happened? How many solutions? 0. Okay, so 0 solutions. All right, let's look at this one now. Okay, so now all that happened between these two here was we shifted the graph a little bit. We added a little bit more to it. Look at this one here. We're adding a lot more to it this time, right? We've got a square root and another function. So we're going to put those in as separate and see what happens with our solutions. Okay. All right. Did it change my, I'm looking over here. Oh, no, it did. Okay, so we're going to put in y equals the square root of 4x minus 4. This is annoying. And then at y equals x plus 1. All right, how many times did they cross? 0 times. Okay. All right, here's what I want you to do. I want you to go through, okay? I'm going to give you like 3 minutes to do this, okay? I want you to go through. You're going to have to replace, we're going to do this one, and then I want you to do all of D. Okay, so you're going to have to put in 2 new equations for D. Okay, so I'm going to give you like 3 minutes. I want you to go through on Desmos and find all of those, how many times they each cross. Okay? Everybody's trying it, so I should see a Desmos up on your screen. You're doing this. I give you about 30 more seconds. So we're going to look at them together, okay? Okay, so I went ahead and I put them all in there so that we can kind of do this real quick, okay? So that was the first one we already talked about. So this one was the square root of x minus 4 and 1/2 x. How many times does it cross? 2. Okay, so we're going to put a 2 in for that one. Okay. So 2. All right, then I had to do with 2x minus 5. So there's 2x minus 5. How many times? 1 time. Okay. All right, 1 time. All right, now we're going to do square root of 2x minus 3 and square root of x. So square roots on both sides. Doesn't that sound exciting? All right, so we got that one and that one. How many times does it cross? Once. Okay, good. All right, so 1 time. And then they want us to take out the square root and put in square root of x plus 3. Uh-oh, look at that. When do they cross? They never. They're like parallel, right? Even though I kind of usually we only use that with lines. They seem parallel. Okay, they're not, but they seem it that way. All right, so no times. Okay. So really, what we're talking about here is looking at the number of solutions. If I just have it equal to a number, notice these ones were just equal to numbers in A and B. What were our only possibilities of solutions when I was equal to a number? 1 and 0. Okay, so that's what this first one is talking about, this first question. When our square root is equal to a number, there are either 0 or 1 solutions. Okay. And then they went on to ask about this one. It's still equal to a number. So this was from the second part. When I went and did this one here, it's still equal to 0 or 1 solutions, right? When I just added the little bit of extra on, 0 or 1 solution. I don't know why it doesn't have one for when it's equal to a variable. Or equal to when we have square roots on both sides or a variable on both sides, it could be how many? 0, 1, or 2 solutions. So I could have up to 2 solutions on this, okay, when we're looking at actually solving these, okay? When I have that, we're talking about square roots here, okay? Quadratics are going to come back in. That means all of our factoring is going to come back. Our quadratic formula is going to come back. We're probably going to ignore completing the square, okay? But all of that stuff with the squares, all of it all intertwines is going to come back when we're trying to solve these. Extraneous solutions come back, okay? One other thing I want to point out before we lose Desmos here, okay? If I am looking at, let me just go back to, I'm going to go to the parent graph, y equals square root of x, okay? And I want to also go y equals x squared, okay? We talked earlier in the year about how those are inverses of each other. And basically, if you took this line that's right there, that invisible line, you could fold it over top and they'd be inverses. What's missing doesn't it look like half the graph is missing when I come down here? Yeah, so what's going on is when you take the square root of both sides, aren't you supposed to get a negative and a positive? So if I put the negative in there, we would get the full parabola back. We don't do that because remember we talked about the vertical line test. If I did the vertical line test on this, it's no longer a function. So that's why they only work with 1/2 of it, okay? So obviously if there's a negative in it, right, it reflects it across. It's a reflection of it, okay? So that's where it's coming from, the little background on the graphs. We're going to work on the algebra inside, okay? All right, here's what I want you to do. I want you to take a minute, maybe a minute and a half. I want you to read through those paragraphs, right? We're improving our RI scores right now, right? By reading math. So everybody's reading. You can go, Brooklyn. Yeah, you have your ID. Okay, thanks. I put it in for 19, okay? So just watch the clock. All right, let's take a look and let's talk about the definitions. There's a lot of definitions embedded in there that you just need to make sure that you're aware of, okay? So let's start with a radical equation. When we have an equation, what should we have in it? What makes it an equation? Equal sign, right? Versus an expression. So expression is something we simplify. Equation is something we solve, right? In this case, 0, 1, or 2 solutions, okay? It's basically a radical equation. It has a variable with a radical or a variable raised to a non-integer rational power, okay? What that means, another word for rational that we talked about is fractional. It's talking about an exponent, right? Power is an exponent. It's talking about something like x to the 1/2 power. So instead of having a square root of x, remember these two things are equivalent to one another, it's saying x to the 1/2, okay? So either way, we're going to deal with it the same way. It might be cubed root of x or x to the 1/3 power, okay? Because we're going to have some cubes get thrown in here, okay? All right, to solve a square root equation or equivalently, an equation involving a power of 1/2, look at it, gave us the instructions right here. Doesn't it tell us what to do? Square both sides of the equation and solve the resulting equation. We square both sides, okay? What we do on each problem might be a little bit different from there, okay? Because opposite numbers have the same square, squaring both sides of an equation may introduce an apparent solution that is not an actual solution, meaning we could get something extraneous. So here's what might happen. They give you an example. Well, the only solution of x equals 2 is 2. If I square both of them, I get x equals 4. But let's think about this. If I take the square root of both sides, what am I supposed to put in front when I take a square root? Plus or minus. So I get x equals plus or minus 2. So it's possible that you get a solution. We got that -2. That might not be a solution of the original equation, okay? And that's where we want to test and make sure we put things in. If you end up with a negative number under a radical, we know we can't have that, right? That can't be a solution because it's something that's not real, okay? So you don't want that to happen. All right, let's keep going. I don't know why there's so much space. All right, let's look at this one. You're going to notice out there in the left-hand column, it's a Delta Math homework assignment. I don't know if I put it out there, not yet, but I will make sure it's out there before the end of this day. I told you what problem it looks like. So if you need help, because sometimes Delta Math's help isn't like the way I taught it, right? So if you need help, go back and look at your notes. If you're doing one that's Delta Math level 2, it's like this problem, okay? So instructions say, solve the equation, make sure you're checking for extraneous solutions. That means just test our answers at the end. Make sure you don't get a negative under a radical, okay? All right, before I can square both sides, I need to make sure the radical is isolated. So I am going to move the 2 to the other side. How do we do that? Subtract. So same algebra we've been doing forever, right? So square root of x plus 10 equals x minus 2. All right, here's where it gets tricky and ugly, okay? So these are not, you know how to do every step of this problem. We've done all the background algebra. The only new thing is the radical, okay? It's just a lot of little tiny problems that we've done before, all in one problem, okay? That's what makes it ugly and tedious, okay? All right, to undo a square root, what do? Square. And whatever I do to the left side, I have to do to the right side. Look at what I just did to the right side, though. I put parentheses around the whole thing and squared it. Because there's a minus sign there, we can't just square the x and square the 2. Okay, so you have to do the whole thing. It turns into a binomial squared. Okay? All right, we know the square and the square root do what? Cancel. So I get x plus 10 equals. All right, you're going to get really good at saying this right now, okay? When it's squared, that means we write it twice. Okay? Squared equals write it twice. It does not mean square the x and square the 2. You have to write it twice. Okay? If it said cubed, how many times would we write it? 3 times. Okay? All right. Now that we have this, what algebra do we need to do a binomial times a binomial like that? That's a FOIL problem. Or if you want to get out the box, you can use a box on it. I don't care. You pick. Okay? So x plus 10 equals. We're going to FOIL in our heads. Okay? So what's x times x? Good. X times -2. Now, how many of those do I have? 2 of them. See how I have 1 here and 1 here? So I've got -2x and -2x is going to be what? So notice I did that part. I did the middle in my head. We're in second semester Algebra 2 at Trig. We should be able to do that. If you can't, write it out. Or do this off to the side, right? There's no shame in doing that to the side and just kind of writing it down so you can see it. Some of us are visual and need to see it. Okay? All right, -2 times -2. +4. Good. All right, whenever we have a squared, remember we call that a quadratic. In order to solve any quadratic, no matter how we're going to solve it from here, what does it have to be equal to? 0. Do you see how everything is coming back to quadratics? Every single thing we've done this year has come back to this, okay? You got to be good at them, right? There, you can't pass without quadratics. All right, so we got to get it equal to 0. I am going to choose to try to keep that leading coefficient 1 and positive if I can, right? So I'm not going to move things to the left. I'm going to move things to the right, all right? Because I want to keep it positive and 1. Because I don't want to have to do a box if I don't have to, okay? All right, so I got to move that x to the other side. How am I going to do that? Subtract it. So I've got 4x minus x is what? And you don't have to write that little minus x if you don't want to. If you can do it in your head, do it in your head. Okay. How do I move the 10 to the other side? Subtract it. So what is 4 minus 10? Good. And I've set it up to equal 0 on the left. Okay. Okay. I have a trinomial that I need to solve. We're going to magic x, right? Our brain should go magic x. If magic x doesn't work, then we use quadratic formula. Okay? All right, so good old magic x, two numbers that multiply to -6 and add to -5. Everybody okay? Oh, wait, that didn't work, did it? Okay, what else can I use? It's okay. Your brain's growing. We're good. Okay. -6 and 1. Everybody good with that one? Yeah? Yeah. Okay. That's cool. All right. So we got, I need a box. No, I don't have a leading coefficient, so I don't need a box. So 0 equals x minus 6 times x plus 1. Okay, we're going to use this property about a million times here in this unit, in this section. Okay. We now need, what's the name of the property? Do you guys remember? Good job. Zero product property. So x minus 6 equals 0 and x plus 1 equals 0. All the zero product property means is to split that up, right? And now I got to solve. So I get x equal to 6 and x equal to -1. Now I need to test my answers, okay? I actually wrote something down wrong up there before. I cannot have a radical equal to a negative number. So this is a no-no, okay? So all I really have to do is I'm going to come back up here to this line right here. I'm going to ignore my little squareds on it because that was me doing work. And I'm just going to look at this and this, okay? So I'm going to test into there. I did not leave myself a lot of room to test. So I'm going to test my 6. So I've got 6 plus 10 equals 6 minus 2. All I really care about is this number right here. Is that going to be positive or negative? Positive. So that means that's probably a good answer. I could do the work, right? Square root of 16 is equal to 4. It works. Okay. All right. I'm going to test the -1 now. So -1 plus 10 equals -1 minus 2. Is that going to be positive? No, I cannot have a square root of a negative and it equal a negative number. It's impossible, okay? So that's extraneous. Remember what we do? We don't erase it. We just put a nice little X through it so Mrs. Ballard can still see your work, right? And when we type our answer in for the test or the quiz, we just type a 6, okay? So we had an extraneous solution that time, okay? Normally I leave myself and I'm able to do my testing right underneath there. That was bad spacing on my part, okay? All right, we're going to see if we can get in a couple more, okay, before we don't have that. Well, actually, we do have more because I made the lesson longer than last year. Put more in it. Okay, so on this one, it looks weird, okay? We have a 1/2 power and a 1/2 power. It's no different than having a square root minus a square root. When I see something like that, I'm going to move this to the other side to begin with, so I can easily square both sides, okay? So I have x plus 6 to the 1/2 equals 2x minus 4 to the 1/2. And it might be set up where it starts by looking like that. That's actually the easiest one, okay? We'll see why in just a second. All right, when I have a 1/2 power or a square root, go ahead. When I have a 1/2 power or a square root, how do I undo that? Square both sides. So I'm squaring both sides. Okay. What happens with the square root and the 1/2, or the square and the square root? It becomes 1, or they cancel, right? So look at what's left here. X plus 6 equals 2x minus 4. Is it a quadratic this time? No, you want this problem on the quiz, right? Way less work. Okay. I just have to get x by itself. Okay, so what should we do? Okay, subtract 6. All right, I like that. Okay, so what's negative 4 minus 6? Good. And at the same time, what else should I do? Bring the 2. I would take the 2 to the other side. How do you take the 2 to the other side? Subtract it. So it's x minus 2x. Negative x. Okay, and then what do I have to do with the negative? Divide it. So my answer is x equals 10. We really should check, okay? When you're in this situation, it usually is a solution, but it doesn't hurt to check it. So I'm going to go ahead and put it into this with the 1/2 and this with the 1/2 just to double check, okay? So 10 plus 6 to the 1/2, does that equal 2 times 10 minus 4 to the 1/2? I put way too many parentheses. Okay. What's 10 plus 6? 16. This is basically saying the square root of 16. What's the square root of 16? 4. So I know this side is 4. Okay. All right, what's 2 times 10? 20 minus 4 is what? 20 minus 4. Do I even need to worry? It was 16 and 16. Isn't it the same thing? Yeah, so that's a good answer. It works. Okay. All right. Let's see, we're out on time. 24. Okay, let's see if we can get through one more. Okay, this one's going to be uglier. All right. Okay. Do you see how we've got... There really isn't a good way to undo the radical. We're probably going to have to do... Notice this one went to a level 3 all of a sudden. Okay. We're probably going to have to do a couple of rounds of squaring and things on this one. All right. So the only thing I can do is start squaring both sides. That's how I get rid of this radical here. But when I do it here, I have to square it like a binomial. Okay. So on the right side, what happens with the square and the square root? They cancel. So we've got x plus 6. When I square a binomial, what does that mean? Write it twice. Good. So I've got square root of x plus 2 times square root of x plus 2. The algebra is going to be ugly. Okay? It's just the way it nature of the beast. Okay? All right. What is square root of x times square root of x? It's really this, right? I'm going to write it over here, and we're going to take a shortcut. It's square root of x squared. What happens with square root of x squared? So it's just what? X. So a radical times itself is the junk underneath the radical. It's just an x. Because we're foiling right now, right? Okay, square root of x times 2 is 2 square root of x, right? How many of those am I going to have? Because I'm multiplying square root of x times the 2. And you can't put the 2 inside the radical, right? Insides and insides, outsides and outsides. They don't mix. Okay? All right, so and now we're just going to do the coefficients in front. What's 2 plus 2? 4 square root of x. Okay, now we're going to do the last. What's 2 times 2? 4. Good. Okay. Do you see how there is still a square root? Not pretty, right? I still have to isolate that and square both sides again. Okay, so this problem got a lot more complicated than the last two. I'm going to just try to get that square root by itself. Okay, so how do we move this x to the other side? Subtract it. Hey, just what just happened? What's x minus x? So those end up canceling. That's actually kind of nice, right? All right, take that 4 and put it over to the other side for me. Okay, well, I get the phone. Okay, so move that over. and then divide by the 4 for me. Okay? Move this over and divide by that 4. What's this value? Yep. Fine. That if you're going to attendance. Okay. All right. What did we get? What was 6 minus 4? 2. Okay. And then we've got this 4 square root of x. Okay, how do I move that 4 to the other side? I heard every operation. It's right now multiply. What's the opposite? Divide. So I've got square root of x equals 2 divided by 4. Can I reduce 2 divided by 4? What's that reduced to? 1/2. Okay, so not terrible. I'm not going to have to do a solve a quadratic. That's actually nice, right? Even though this was a little uglier in the middle. How do I undo a square root? We have to square both sides, right? What happens with the square and the square root? Cancel. So I get x equals, what's 1/2 squared? So remember, you square the top and square the bottom. What's 1 squared? What's 2 squared? 4. We're squaring both of those. Okay? All right. Should I probably check my answers? Isn't that what I'm supposed to do? Yeah, okay. So I am looking at, I'm going to go back to this original here. Okay? So I've got the square root of 1/4 plus 2 and the square root of 1/4 plus 6. All I'm really concerned about is that I don't have a radical equaling a negative number. Okay, so I'm not going to do all of that math. Okay, what's the square root of 1/4? 1/2. So is this radical over here equaling a negative number or a positive number? That's 2.5. It's going to be positive, so I'm pretty confident that that's a good answer. Okay. All right. Here's what's going to happen. We're going to finish this lesson tomorrow. Okay. We've got a couple more that we've got to deal with. Okay. And then we're going to probably quiz on this. You're going to want to be working on homework. We're going to quiz on this probably Tuesday-ish is my guess. We'll also be re-quizzing the other stuff, later in the week next week. Okay. So we're going to, because we want to make sure you've got a good start to this. Make sure you're practicing. I will put the homework out there so you can start practicing tonight. Okay. But I'm going to stop now because I think that's enough, right? Because they're going to come on with announcements maybe soon. All right. I think our brains have had it. Thank you. Thank you.
Okay.